Let's start with the topic of geometric progression. First, let's look at the definition of geometric progression. A geometric progression is a sequence of numbers in which each term can be obtained by multiplying a certain quantity to its preceding term. Right? Let's understand this better with an example. So if you look at this, we have a sequence of numbers here: 3, 6, 12, 24, 48, 96, and so on. And if you notice, I can I can obtain each of these numbers by multiplying a certain quantity to the preceding term, right? So the keyword here is multiplying. So if you notice, 3 multiplied by 2 will give me 6, multiplied by 2 will give me 12, multiplied by 2 will give me 24, multiplied by 2 will give me 48, and multiplied by 2 will give me 96, right? So what we've done is we've multiplied 2 to each preceding term to get the next term, and such a series of numbers is called as a geometric progression. Let's look at another example here. 400, 200, minus 200, 100, minus 50, 25, negative 12, 1 by 2, right? So again, if you notice here, 400 into negative half or minus half will give me 200, minus 200. That into negative half again, right, will give me 100. That into negative half of, or 0.5 will give me negative 50. Into negative half will give me 25. Into negative half will give me 12 1 upon 2, minus 12 1 upon 2, right? So here as well, if you see, we've multiplied each preceding term by minus 1 by 2, or you could also say that we've divided each term by 2, but let's stick to nomenclature of multiplication. All right. Now there are certain parameters of geometric progression that we need to know, so let's talk about those. So if you notice here, this is the first term, so we'll consider the first term as t1, second term t2, third term t3, fourth term t4, t5, t6, and so on, right? So t stands for term, and the subscript here tells us the position of the term, right? So term 1, term 2, term 17 would be t17, and so the nth term, right, like the general term, nth term would be denoted by tn, right? So these terms keep going on like that, where n here denotes the position of the term. Okay, so that is one thing, tn, the nth term. Now another important parameter, like over here, if you see the first term that we have, t1, yeah, 3 over here, right? So the first term, for the first term, we have another variable that we use. So the first term, which is t1, is also denoted by the variable a. Right? The first term generally be denoted by the variable a. Another very important parameter in the case of a geometric progression is, if you notice, 3 into 2 gives me 6, 6 into 2 gives me 12, 12 into 2 gives me 24, and so on. So that is that certain quantity that we are multiplying into each term, right? And that certain quantity is called as the common ratio, right? The common ratio, okay? And it is denoted by the alphabet R. The common ratio is defined as the ratio between any given term and its preceding term in a geometric progression. So if I want to find the common ratio, I can find it by dividing term 2 upon term 1, right? Or also by term 3 upon term 2, or term 4 upon term 3, and so on, right? Any given term divided by its preceding term in a geometric progression will give me the common ratio, right? So these are the two important parameters, the first term and the common ratio. With the help of that, we can find any given term. We can find any term in the geometric ratio. Any term means, by that I mean the nth term, and the formula for that nth term would be discussed in the next video.